Okay, what we're going to do today is we're going to do lesson 12.5 and 12.6. We're going to start out with 12.5, which is the Pythagorean theorem, okay? A lot of you have probably already heard about or learned the Pythagorean theorem before, especially if you took pre-algebra before this, okay? What the Pythagorean theorem does is it tells us, or it gives us a formula for us to find the side lengths of a right triangle. Okay, a right triangle has a 90-degree angle. That's what makes it a right triangle, okay? Normally, this little box right here tells us that that is the angle that is 90 degrees. That's why they have it there, okay? So what you're going to have to do is you're going to have to know, okay, or memorize the Pythagorean theorem. This is the formula here. A squared plus B squared equals C squared. I want everyone to write this down. One of your test and quiz questions is going to be, write the Pythagorean theorem. So you will have to know this formula right here. You're going to have to memorize it, and you're going to have to know how to use it. All right, we all know that a triangle has three sides. So each of these letters represent a side of a triangle. The A and the B represent what we call the legs of the triangle. Now, the legs of the triangle are the two sides that are connected by the right angle box. That's how I always know what the legs are. And the legs, okay, they do not matter which order they're in. This could be A and this one could be B, or, okay, this could be B and this could be A. It does not matter which order the legs are in. We could do A squared plus B squared, or we could do B squared plus A squared. All right, the legs are interchangeable. However, our hypotenuse. The hypotenuse is the longest side of a right triangle. That is C, okay? The hypotenuse always has to be in the equation on the one side by itself. It can never be interchanged with A or B. Never. A or B have to be on one side, and C has to be on the other. Okay? What I can do is they'll give us certain links, side links, and they'll say, find the missing one. Okay? And that's what you use the Pythagorean theorem for. And again, I said it on the last slide, it only works for right triangles. So in this first example right here, what they've given us is they've given us 2 out of the 3 side lengths, okay? And they want us to find the third one. And I drew this little example triangle over here because I know for a lot of people they're visual learners, and so it's easier to see the actual side lengths on the triangle. So we'll use it to plug in our values. What they've told us in this first example is A is equal to 8 and B is equal to 15. What is C? First of all, which one of these letters is my hypotenuse? C. Okay, I have to know that. So, on this example triangle right here, I know that my legs are going to be this side and this side because they're connected by the right angle box. And so I know that A is 8 and B is 15. But I do not know what C is. Okay, C is always the hypotenuse, the longest side of a triangle. So what I'm going to do is I'm going to use my formula, A squared plus B squared equals C squared, to find out what C is. So I plug in my numbers. 8 squared plus 15 squared equals C squared. First step, what you always do is square everything you can. So 8 squared is 64. 15 squared is 225. Equals C squared. I can't square C because I don't know what number it is. All right? Now, I want to combine like terms. 64 plus 225 is 289 equals C squared. Now, I want to find out what C is, and C does not equal 289. In order to do that, okay, I'm going to have to do the opposite of what is happening right now to C. C is being squared. So the opposite of that is the square root. Whatever I do to one side, I've got to do to the other. When I square root it, it cancels out that squared, and I'm just left with C. And the square root of 289 is 17. Now, a lot of people right here go, okay, do I need to put positive, negative 17? No, because whenever you're measuring something, there is no such thing as a negative measure. When you measure something, you're taking up space. Okay, you're never going to be able to have a negative measure. Okay, that would mean it doesn't exist minus some more. Okay, so it's always going to be positive. All right, so let's do the Pythagorean theorem again whenever they give us A and C this time. So I'm going to erase my values off my triangle and rewrite them. A is 2, B is we don't know, and C is 7. So I'm going to use my formula, A squared plus B squared equals C squared, and plug in my numbers. 2 squared plus B squared equals 7 squared. 2 squared is 4, plus B squared equals 49. Then I want to combine like terms, so I subtract 4, and I get B squared equals 45. Then I need to get B by itself, so I do the square root of both sides. Now, if you notice right here, 45 does not have an exact square root. So what I have to do is I have to simplify the radical, which is going to be 3 times the square root of 5, which I would know that by either plugging it in my calculator or doing upside down division. Okay? So I never, ever, ever want you to change this to a decimal. I want you to keep it as a radical expression. Okay? Anybody have any questions about how to keep it as a radical expression? Okay, so the next example that we have is determine if it is a right triangle. So what they've done, okay, is they've given us all 3 side lengths already, okay? And they want us to find out, is it a right triangle? Remember, we said this before, the Pythagorean theorem only works on right triangles. You can't use it for every single triangle that's out there, okay? It only works for a right triangle. So what I do is I can plug these numbers into the Pythagorean theorem and see if they equal one another. But before I do that, you look at these triangles and you go, but there's no 90-degree angle. So how do I know what the legs are and how do I know what the hypotenuse is? Okay, this is all you do. The legs are interchangeable, so it's most important that I know what the hypotenuse is, because C has to be on that other side by itself. C will always be the biggest number. So I look at this first triangle. C has got to be 29. It will never be one of the smaller numbers. It's always the largest. And then it does not matter which one of these other ones I make A and which ones I make B. I can make 21A and I can make 20B, or I can make 20A and 21B. It's not going to make a difference. Okay, so I plug it in. 21 squared plus 20 squared equals 29 squared. And I knew my hypotenuse was 29, so I had to put it on the other side. I just plugged it into the Pythagorean theorem. Now, what I do is I square all of these numbers, okay? 21 squared is 441, plus 20 squared, which is 400, equals 29 squared, which is 841. Now, all I need to do is figure out if these added together equals C. 400 plus 441 does equal 841. So since it checked out, since they equal one another, yes, it's a right triangle. Okay? And I don't want you just to write yes on these. I want you to acknowledge that it is a right triangle. So you need to write yes, right triangle, or yes, it is a right triangle, or you can write right triangle, and then for ones that are not, put not a right triangle. Okay? But I want you to identify that it is, in fact, a right triangle. You're not just saying yes because it's a solution. Okay? Now let's do this next one. Which one of these values is my hypotenuse? Josh?
12.
12. Very good. So I know no matter what, I can put 5 and 11 in any order as long as 12 is on the other side. So I'm going to do 11 squared plus 5 squared equals 12 squared. 11 squared is 121 plus 5 squared, which is 25, equals 12 squared, which is 144. Add it together, and I get 146 equals 144. So is this a right triangle? No, it is not, because the sides, it does not equal one another. So not a right triangle. And I'm just using the symbol for a triangle instead of writing the word all the way out, which you can too. Okay? So whenever they do not equal one another, I know it is not a right triangle. Okay, so now we're going to move on to lesson 12.6. 12.6 deals with two other formulas, the distance and the midpoint formulas, okay? We can use these formulas in order to find the distance between two ordered pairs and the midpoint between two ordered pairs. We can eventually use this when we're dealing with triangles, which we will do at a later time, not today, okay? So in today's lessons total, you will come out with 3 formulas that you need to memorize. The first one was Pythagorean theorem, a squared plus b squared equals c squared. The next one is the distance formula, okay? Now this distance formula looks really hard and complicated, like it would be something that, you would use in calculus, but it's not, okay? It's actually very simple. It just has a lot of different numbers to signify different things. So we have d equals, which d stands for distance, d equals the square root of x2 minus x1 squared plus y2 minus y1 squared. And what you're going to use this for is you're going to use this when you have two ordered pairs and they want you to find the distance between the two of them. So I could have something like 2 and 6 and 5 and 1, and they want me to find the distance between these 2 points, because it could look something like this. Normally, if it was a point that went straight across, well, I can find the distance. It just goes 4 over or whatever it is. But when it's a diagonal line, it's not usually that easy. So we use the distance formula. And what these numbers right here are called subscripts when they're small and they're below. All that those do is they tell me the distance between x1 and x2, or they tell me the difference between x1 and x2. It's like having 2 people in your class that have the same name, okay? If I had a Ryan C and a Ryan S, okay? I would know the difference between Ryan C and Ryan S because of the C and the S, okay? That's what tells me the difference between the Ryans. That's exactly what tells me the difference between the X's and the Y's, okay? So, let's use the distance formula. What I'm going to do, all right, is I'm going to use the formula. I'm going to go ahead and write it. D equals the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, now let me let you in on a little secret. It does not matter what order you put the x2 and the x1 in. As long as you have the x's in that parentheses, it does not matter. And I'll show you in a second. So I normally always like to put in the x's as I see them. It does not matter the order. But 90% of the mistakes that are made on these problems are because people look at this and they go x, x, y, y. Is that how an ordered pair is written? No. An ordered pair is written x, comma, y and x, comma, y. You have to remember that. Another easy mistake that people make is they say, okay, x is 5, x is negative 3, and then they go to write it in and they write 5 and 7. They just quickly glance and they accidentally write the wrong ones in. So just check, double check what you're doing, okay? And I like to plug them in exactly like they give them to me. So I like to start with 5 minus negative 3 squared plus negative 1 minus 7 squared. Now, what do those 2 minus signs do? Turn into a positive, okay? Five plus 3 is 8 squared plus, what's negative 7 plus negative 1? Negative 8 squared. Okay? What is 8 squared? What's negative 8 squared? 64. Exactly. I do not make that a negative 64 because negative 8 times negative 8 is positive 64. D equals the square root of 128. Now, does 128 have an exact square root? No, so I just need to simplify. And the distance is going to be what?
8 times the square root of 2.
Very good. 8 times the square root of 2. And that is the distance between the ordered pair 5, negative 1 and negative 3, 7. All right, now let's do the next problem. So we're going to do, this is x and y, and I use my distance formula. D equals, I've got 1 minus negative 2 squared plus 4 minus 3 squared. D equals, that changes this to a positive, 3 squared plus 1 squared. 3 squared is 9, 1 squared is 1, and I get the square root of 10. Now, can I simplify the square root of 10? No, there is absolutely nothing I can do, so this is my final answer. All right? Now we're going to our third and final formula for today, which is called the midpoint formula. Midpoint formula, okay? We've got, what the midpoint does is it tells me if I have a point here and it's connected to this point here, what is the exact middle point between those two? What the midpoint, the formula tells me is exactly how to find that midpoint. Because like I said, when you have a horizontal line, it's really easy to find a midpoint because you could just look and figure out between the two numbers what's exactly in the middle. But when you have a diagonal line, it may not be that easy. Okay? So this is what I do. I would use the 2 points that I've been given, plug it in the formula, and then I will have an ordered pair. If you notice, okay, this formula is written as an ordered pair. It's in parentheses and it has a comma between the x and the y. So what you're going to get is an ordered pair as your answer. Okay? Again, you will have to memorize this formula. It will be on your test. All right, so they want me to find the midpoint. Again, it does not matter what order the x's and the y's are in, as long as the x's are being added together and the y's are being added together. So I have x comma y, and I'm going to plug it into my formula. Negative 2 plus 4 divided by 2. And then I have 3 plus 2 divided by 2. Okay, and I just simplify. Negative 2 plus 4 is 2 over 2. 3 plus 2 is 5 over 2. Okay, 2 over 2 is 1. 5 over 2 is 2.5. Okay, you can keep it as 5 over 2, but I always feel like it's much easier, since this is an ordered pair, a point on a graph, it's much easier to find a mixed number on the graph than it is to find an improper fraction. All right, so the midpoint between the point negative 2, 3 and 4, 2 would be 1 and 2.5. All right, let's do the last one. I've got x1, which is negative 10, plus 15 over 2, and it will always be over 2. That will never change. And 10 plus 18 over 2. I have 5 over 2 and 28 over 2, which equals 2.5 and 14. So this is my midpoint for those points.